this lovely day, we're going to find areas of circles and sectors and segments of circles. So we're going to use this supersecret formula. I'm going to start off by writing it down. The reason we write it down to begin with is because when we have it written down, it's being ingrained into your brain all the more. So I quickly recognize that this is my R for radius. So I could just substitute in. 9 goes right there. And my exact answer is this. 81 pi meters squared, or square meters. That's an exact answer.
Multiply that times pi.
So 81 times pi, so 81 times 3.141592654 will get you approximately this value right here. And it is square meters, and we box or circle the answer. Boom! Hashtag, we got it going on. So as we see in this diagram, boop, 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 salud. This is my diameter, is 6.3. So I need to divide that puppy by 2 in order to get R. So 3.15 is the radius.
What are the two formulas for them?
When I plug and play here, it's going to be pi times R squared. And we substitute in pi times 3.15 squared. So my exact answer here is, so it gets kind of ugly. So I'm going to change this to an approximate value, 9.22 pi feet squared. And 31.17 feet squared. All right, so let's take a gander at where this comes from. This is actually from an ancient text. And I'm forgetting if it's Japanese or Chinese, but they have found it on an old scroll, and like 2,000 years old at least. It's really awesome how this is derived. Okay, number 1, we know that anything from the center to the edge is called the radius. Good to go? Which means if I take this circle and slice it up like pizza, and then lay the pizza out, but alternating. So one slice down, one slice up, etc. Like this. Notice that the R, a radius, is now an R radius right there. So the edge of this new shape down here, which by the way almost looks like a parallelogram, is R. We also know that the distance around we call the circumference, right? So the circumference is equal to 2 pi times R. But look at this. How much of the circumference is this right here? 1, 2, 3. If you go all the way around. How much is that the circumference? Yep.
Half.
It's half of it. Why? Because the other half is down below, right? The crust of the pizza is all around there. So if I were to consider this as a parallelogram, and I say, well, area is base times height, I know what the height is. The height is R. And what's the base? What would this distance right here be? It's 1/2 circumference. So area is 1/2 the circumference, because that's the base, times the radius. But we know what circumference is. We already have a formula for that. So 1/2 of 2 pi R times R. That's, I just replaced circumference. Notice what happens with the 2's. They drop out. And so we end up with area is pi times R, which is pi R squared. Boom! Now you can go on. Now you can go on. That's just beautiful. These ones here are, we'll just go quick through because we already know pretty much what to do. Area is pi R squared. Of course, the radius here is 7.5 because I cut that in half and square it. 56.25 pi centimeters squared. 176.71 centimeters squared. And there we go. So finding areas of circle, no big deal. It's mostly review for us.
Floyd.
Is what if we don't want to find the whole area of a circle, but only a partial piece of the area of the circle. So that brings us to pieces of pizza. So if you have a circle, and you cut a central angle right here, this whole unit is called a sector. It's called a sector. So think of it as a slice of pizza. That is a sector. So if we're trying to figure out the area of how much pizza you're eating in square inches or whatever the unit is, then this is what we're considering. So not the distance around like the crust or how far we've walked if we walk partial circle, but it's how much pizza we've eaten or how much cheesecake that we've delved into. Pie. All right, so area of sectors is very simple, like this.
Can you go back to that second?
Area. The problem with this one, area of a sector, there really isn't a shortcut. They don't have like an L or something like that. So if you just want to say A for area, that's fine too. But remember that the area of the sector is exactly as the formula we did before. It's the part of the circle. So this piece right here is going to be a fraction, usually. A fraction or a decimal right there. And this, of course, since we're talking about the circle, we're going to say pi r squared. We're talking about area of circle. So our super secret formula, and I'll just use A for area, is going to be whatever your measure is of the sector's arc divided by 360 times 2 pi r, excuse me, I got too excited there, pi r squared. So we're going to plug and play here. We're going to find the area of the shaded region. We're also asked to round to the nearest hundredths, but also we're going to put it in pi, in terms of pi. So since I have a 90 degrees here, a right angle, I know that this is 90. So if I wanted to simplify now, I know that 90 over 360 is equal to 1/4. So using this fraction might actually be easier in my area formula. So the area of the sector is 1/4 times pi r squared. When we reduce here, a couple different ways to reduce. The fastest is this. If I divide this by 4 to get a 1 and divide this by 4, just one of the exponents goes away. If you had a hard time understanding that, just multiply this out to be 16 and then divide by 4 to get back to 4. So the exact answer is 4 pi. Since there aren't units, I'm going to say u squared for units. And the approximate value is 12.57 square units. Box or circle your answers. All right, next one. I'll just walk through this one. The area is the same formula. Here, if you will see the 45 degrees over 360, you can see quickly how that reduces.
1 over 8.
1 over O, chito loquito. So the area is going to be 1/8 times the area of my circle, which is pi times 3 squared. Now notice things don't reduce so well like they did in the previous problem. And here's my actual answer. 9 pi over 8 square units. That's an exact answer. About 3.53 square units. When you commit to your answer, put a ring around it. Now we can do area is 1/10 of pi r squared, r being 6. And now if you see the 3/6 over 10, that still reduces to 18 over 5 pi. So there's an exact answer, 18 pi over 5.
How do you get 18